Alright, so let's do 12 methods in Unit 3 and 4. Let's go. Unit 3 topics, yeah, that's what, topic 1, 2, 3, logs, differentiation, integration. Logs, just know the log laws, see the formula sheet if you can't remember, and just look at the graphs, and just have a play around with Desmos to see what the difference is. Okay, differentiation, just know the formulas here, and yeah, also if you can't, you need to know about the limit here. This probably won't show up, but just good to know. Limit as h approaches 0 of e to the h take 1 over h equals 1. Any other basis results in L and D, so that's your formula for differentiating any exponential. Integration, just reverse power rule and chain rule here in methods. So that's pretty much it. Also have the integral that results in an ln. No need to do absolute value, ignore I said that. And let's see, another fundamental theorem of calculus, just trapezoidal rule, just cutting this area up into trapeziums. Also, differentiation from displacement velocity to acceleration, integration reverses it, and just make sure to be able to do definite integrals from a to b of f of x. Just make sure if you don't know how to do this, Unit 4 is going to be a bit tricky. But applications of integration, just area between like two curves, between bounded by the x-axis. Yeah. Now, Unit 4, you have second derivative, trig functions, discrete random variables, continuous random variables, and normal distribution, and interval estimates for proportions. Second derivative, I've got the second derivative test on the left, and here's a graph of basically the point of inflection is the change between concave up and concave down. You can see up from negative infinity to 0, it's concave up. No, concave down, sorry. And then from 0 to 2, it's concave up because it's going upwards. 2 to 3, it's concave down. And 3 to infinity, it's concave down as well because it's just continuing on. Yeah, that's as long as you know the second derivative test, it's pretty good if you're forced to sketch in Tech 3. Otherwise, use your calculator. Trig functions too, just remember the ambiguous case and the formulas, just the angle of depression and bearings. They start at north, 0 degrees true, and then a sine rule, cosine rule, just know when to use them. Discrete random variables, they're either success or failures, they're dependent trials, just know the formulas. And then, because I just wrote the standard deviation because it's on formula sheet, just something I would remember is for the third dot point, because calculator allows for cumulative distribution, which is everything up to that one, inclusive, which is not in there for the other way around. Yeah, and there's binomial if you're doing discrete. I put a conditional probability there because you probably get a question on that. Continuous random variables, area of the curve is probability, and if we're using, that means we're doing integration. So, yeah, we integrate a function that's above the x-axis, because if it's below, probability would be negative, which is not true. Yeah, we're just integrating cumulative distribution function. That's your p of x is less than x, and if that means for an integral, we just have a top bound of x, and then if you just plug in your any value, you get the cumulative distribution. Yeah, I put the variance formula for what we did in class. You might not have done that, but it just looks better for me. Normal distribution, you just have a standardized normal curve, and yeah, just remember the 60, 95, 99.7 rule with 1, 2, 3 distribution, standard deviation from the mean. I've also got a formula for z equals x take mu over standard deviation to calculate z scores from x scores, because if it's not normally distributed, and then I've got normal CDF, that's calculated from like 2 bounds. Generally, you might have negative infinity to 2 or 2 to 3. And then inverse normals, if you get given a probability, you can find the bounds. Next is interval estimate proportion. They're all random samples for this topic. They're all equally likely to be included. I don't have a better chance of being included than someone the next person. Now, probability from small sample from a small population is without replacement, while if you have binomial probability from a small sample from a large population, it includes replacement. Uh, then normal distribution from large sample from large population. I'll tell you what happens if it is small or large in the next slide. The population proportion is P, yep, it's just number in that attribute over size. Sample proportion is P hat, you can see the formula there, that's how we calculate it. And as I said, large samples are when the mean invariants are greater than 5. As the sample size gets larger, the sample mean tend to follow normal distribution, and it clusters around the true population mean. That's why the expected value of p hat is population proportion. Just also put a standard deviation formula in there. Confidence intervals, yeah, you just remember your z values for the confidence interval percentages. 1.64, 1.96, and 2.58. You may even notice for tech free. Confidence interval is p hat plus minus the error of margin of error, which is plus minus, yeah, which gets your bounds. E is z, which is like your z value here, and multiply by the standard deviation. And that's it. Good luck, guys. For methods, you can do it.